Our next presenter is no stranger to the Water Online audience. He is none other than Stephen Horne with Kaeser Compressors. We are thrilled to have him back. His presentation that he's about to give is how blower selection impacts lifecycle cost. And we do live in a time where something as simplistic as a simple purchase of a blower can equate to really substantial savings. So here to tell us more about that is Stephen. So without further ado, go ahead, Stephen, and take us away.
Okay. Hello, Travis. Thanks once again for having me on the show and the ability to make another presentation. As mentioned, we're going to take some time here to talk about how a blower selection impacts your life cycle cost. And before I do so, I want to do a little review of the last presentation because it's kind of relevant to discussion, but we're not going to get into too much depth on it. But I want to again point out that the history of the evolution of blowers and blower packages. Most everybody should be familiar with the image on the left. This is your basic blower package that you may have in the plant now, or you might see around different plants. It's just the blower and the motor, and you stop this blower. Sometimes you add a VFD to it, which will give you airflow. A lot of times these be talking about your lobe type blowers, and sometimes your multi-stage blowers. In the middle, we've evolved over time to have these blower packages. Again, taking those technologies, but now packaging them from the manufacturer. And these are more highly engineered packages. They come with gauges, sound enclosures, fans, most of the things that you might want to personally retrofit for your plant. And then they get installed and operated. But while they're more highly engineered, their efficiencies are, of course, limited by the technology which is inside of them. And then on the far right, while you can still package those those older traditional technologies into a complete machine, many of these complete high efficiency machines on the market today are your rotary screw blowers and your high speed turbos. These things come complete machines. They have controllers on them, sound enclosures, variable frequency drives, sensor of suites. Everything that you could ever possibly think you need in a machine is now included in these high efficiency machines. So that kind of just covers the evolution of blower packages and where we are today, as Travis indicated, these high efficiency machines. And more on this point, again, this is from the presentation I gave you the last time we had this. So if you're interested in more detail, you can bring that up. But here we're just talking about efficiencies and these high efficiency machines, which operate more in that 70 to 80% in your efficiency range. And then we'll also like to add here is that in this day and age, with sensors and PLCs and computers and algorithms, we can also apply technology to the basins themselves. And here what we're doing, instead of just pumping air into the basin and letting the biological activity happen as it needs to happen, we are now able to measure with sensors being put into the basins to measure oxygen and nitrates at various different injection points along the basins. You have control valves and advanced algorithms, which then help to minimize the losses on the air production side to just make sure you put just the right amount of air into that basin and make that process as efficient as possible. So these are kind of different points I wanted to bring up as we get into your life cycle evaluation. So here is a pie graph. I pull this pie graph up all the time, and I feel like I don't ever get into it in more detail. So for this presentation, I want to dive into this a little bit more. And when we talk about a life cycle cost, we're talking about typically a 10-year period with each blower running about 6,000 hours per year. We need to know what the energy cost is. So we'll assume around 16 cents a kilowatt hour. And we're going to take a look at a very common blower we see out there, 100 horsepower or 75 kilowatt machine. And you can see from this graph that big red portion of this pie is sticking out to represents the majority of the cost, which is our energy costs. That can be anywhere from 80-90%, depending upon what you purchase your machines for and how much you pay for energy costs throughout the country. And that the yellow slice is that machine investment, and that blue slice is for 10 years. It's pretty minimal. It's your maintenance. So that's pretty much going to be your oil, your belts, and your filters. So the cost for that 10-year is pretty minimal for maintenance. Okay, so how do we get this big red chunk in the pie? Well, let's take a look at a 100 horsepower motor. That's about 75 kilowatt. Let's assume that's going to run at that 75 kilowatt for the entire 6,000 hours per year. You multiply your power times your hours, operating hours. That works out to 450,000 kilowatt hours. Multiply our kilowatt hours times our cost per kilowatt hour. That's 16 cents. That works out to just under $74,000 a year in energy costs per 100 horsepower blower package that is running. So you have more than one machine running, just multiples of the machines that are running throughout the year. And of course, if you extract it over 10 years, that's just under $740,000 per blower in energy cost over 10 years. So that's a big chunk of money. And you can see how energy cost and the power that it's consuming is really a dominant piece in this pie. So let's move on to what we spend a lot of our time talking about in this business when we're looking at buying machines. That is the investment cost. So the blower investment cost, that's somewhere in between 7 to 9% of your total life cycle cost. And this includes, yes, the blower. It can be testing. It can be delivery, installation costs, and integration costs. Integration meaning bringing somebody in there to put the controls, algorithms, and getting everything talking and working on site once the machine has been delivered and is connected to the system. Okay, so a little bit of breakdown about how much a blower costs. We'll use a very rough estimate and say it's about $750 per horsepower. We have a 100 horsepower machine, so we'll say it's $775,000 for a traditional lobe type, that's your traditional type blower. This day and age, we're going to want a VFD, so VFD, we'll say it's $30,000. Because these VFD and the blower packages come separate, they'll be integrated and wired up in the field, so we need to have an electrical contractor come in. We'll say that's going to be $5,000 per machine. And then we're going to want to connect that to the plant PLC, so that's another $5,000 per machine. So we're walking out the door, once it's installed and running, about $115,000 per 100 horsepower blower. Okay, so we have this machine running. We established how much it costs. We know how much it's going to cost us per year. We know how much it's going to cost us over 10 years. So the next question is, great, how do we have savings on this? Well, as was alluded to in the opening, we do have new technologies out there which offer us some benefits just by replacing one blower type with another blower type. And these machines are high efficiency blower packages, and they can be anywhere from 20 to 30% better in isentropic efficiency. And again, I covered that in the previous presentation. If we're going to go back to that. And these machines are typically, yes, they're more expensive, right? New machines, new technologies, higher value. But the advantages from an investment standpoint is they will utilize smaller motors. So with a smaller motor, this really helps you make it clear just from purchasing one machine to the next what those savings are. So in this example, instead of using a 100 horsepower machine, we can use a 75 horsepower machine. If we take this, before we move on to that calculation real quick, looking back for isentropic efficiency values, here we have our traditional technologies that have been the workhorse for so many years. That's your lobe and your multi-stage. You can see they're anywhere from 45 to 65% efficiency. And then we get to the high efficiency machines, your screw and your turbos, anywhere from 50 or 60 up to 80%. And sometimes those turbos can sneak above 8% isentropic efficiency. So with that in mind, we go to our 55 kilowatt machine. So 55 kilowatt times 6,000 hours, our new kilowatt hour time our power cost. And now you can see where our energy cost over 10 years has dropped to $542,000 versus $740,000. That is 26% worth of savings. So simply by going from your traditional technology that you might have in your plant and purchasing a new technology, you're looking at 26% savings in power cost per year. over a lifetime of that machine. So that's a pretty significant amount of savings. Now, as I mentioned early on, we also have the plant side. So you combine this high efficiency blower with some additional technology, such as an advanced aeration control system. So now you're going to put probes in the basin. You're going to put control valves and PLC, all these different things in there. And then you marry everything together, and you can achieve additional 20% savings. Again, with this aeration technology, the idea is you're just going to put the amount of air into the basin that the process needs. So we're going to cut back on the waste during production. So you can see additional 20% savings. And go too far. And so over the past couple of years, here's some examples. We have one plant that went from a lobe type to a screw type. They put in probes, added a PLC, and now that plant is reporting 40+% savings month over month from the previous year that they're seeing. So these are some real life examples. Here's another one where they had some old multi-stage machines. And again, they went from 100 horsepower down to 50 horsepower. They integrated into their PLC system. They have better turn down and better control over DO. And this plant is also saving 40+% energy savings. So, this exists out there. The technology is out there. These upgrades are happening. Sometimes it's a bit more complicated. You can see the piping here, but it can be done and is being done. And certainly, if you're out there looking to do that, we would love to help you out with
that. 40% savings in monthly energy bill. That's pretty impressive, David. I know that there's going to be a lot of operators out there that are going to be really interested to hear more about how that occurs and gain more information on what you just presented. So, thank you very much once again for giving our viewers, our listeners, a lot to think about, especially as it relates to energy efficiency and, of course, monetary savings as they run their facilities. So, all really good information. So, if you want more info on what Kaeser compressors can do for you, go ahead and contact them through the link that appears on the screen now. You can always also find them on Water Online. But for all of us here, once again, Stephen, thank you very much for joining us. We cannot wait to have you back.
Thanks so much, as always.